Oh, we got a winner. Is that off already? Hey everyone, we have experiment 6 and this is the Sumo Bot. So with the Sumo Bot, we're going to be putting in this little ramp in the front here of the robot. See the little guy here? Let me show you real quick. It'll be this ramp right here, and we're gonna mount it with this guys on the back, and it'll be something like this, because our little robot is going to try and push other robots out of the way from a ring, from a sumo ring. So typically we have a couple of robots on a ring. It's a black ring like that with a white rim around it. So the robot is supposed to look for the other robot autonomously and try to push it out of the ring while it stays in the ring. So there's only a few rules for this, right? So make sure your robot stays in the dark area. It pushes out the opponent while it's looking for it autonomously. You got 3 minutes for this. First one off the ring, or the one that touches the floor, loses. Okay, and we can have more tries per round. It all depends on our competition. Okay, so this is typically a competition that we do, and if you are just at home and you're testing it, I'll show you how to do some testing. We may have to do the reverse color, for example. We may have to do white in here and then with a black circle around it, a black rim, so to make it simple, but we'll see what happens. In the meantime, this is a photo from a long time ago with some other students, and we have a big ring, and we have let's see, 7 robots in here, and we had a great time. So these were students from different countries, all participating in this. You can see how creative they were. They had different things added to it in the hope that they would win this competition. Alright, so the first thing we want to do is we want to gather a few things. Last time we went ahead and mounted this when we did the line following project, right? So this is already done for you. The only thing you have to worry about now is to mount the ramp in the front. So the way to do that is, see how the ramp still has some of this shads in here, this little guys. You can just pull them out of here like that. Okay, and there's a couple of holes, so you have to decide which one you think will match the best. You know, it depends how far down you want the ramp to go. So you can try the first hole on the top here. So it turns out that actually we needed to install the screws on the bottom holes of here, because otherwise the robot cannot move, because this would be way too low and then it would get stuck. Alright, so you're gonna take basically, these are some of the other components we're gonna use. You're gonna take basically the 3/8 screws and just put it in through here like this. You've got a little screw here and a nut. Okay, so the idea is to, you can see if it's straight by putting it like this. Okay, that seems straight as it's gonna be. Grab the other one And on the top seems to be the best fit so that it can be as close to the bottom as possible. Okay. So what you can see here, when this is mounted, it's almost slow. Actually, let me move this little stand that I have here. Yep. So this is this gives you, I don't know, like 2 millimeters space in between the ramp and the floor. That way you can look for the opponent and push it out. Okay. So next we're going to use some of the longer screws. Okay. So you probably have some longer screws like this, and they'll just go through there, and they will go through there like this. So you'll have one here, you'll have one there, and it looks like according to the holes, it's supposed to be using this two right here. That hole and that hole right there. You'll see that it can only really fit into one place, but you can start putting a nut in. Okay. Go ahead and tighten it up a little bit already while you grab the other screw. And so now you have both of them like this. So any 1 inch screw, even 3/4 of an inch should work. So I'm just going to tighten it up now from here, from the top. Okay. Make sure that it's not touching the floor, but it's as flush as possible. So there's a little bit of a wiggle room. But now we have a robot that can go around, look for the opponent, and try to push it out of the ring. Alright, so the next thing we want to do here is we want to make sure that we have our motors in the right place. So we have pins 11 and 10, just like we've done with all the other experiments, the exact same position. We know how to connect the line following sensor, because this sensor is the one that's going to be looking down for the we're going to probably create a black circle for those of you who are doing this at home instead of using the sumo ring. And I like to use the, I mean, you can use a different sensor if you want. If you want to use the sonar, go for it. But for this one, to look for my opponent, I like to use the infrared sensor, especially because I can control the distance that I can see my opponent at. So you already know how to connect the servos, how to drive them. You already know how to use this sensor based on the previous labs, and you already know how this particular sensors work. So the next thing to do, and here's some more specs on that particular sensor. So you can go all the way to from 2 to 30 centimeters. Remember, 2.54 centimeters is 1 inch. And this is how we will connect them, similarly to like the other experiments that we did. Now for this one, because the rules require that you press a button to start the robot. So in other words, you put the robots in the ring, right? And then you press the button in the ring. And once you press it in the ring, once you press the button of the robots will start looking for each other and try to get them out of the ring. All right, and then the other requirement for the lab and for the actual real competition. By the way, the switches we're using are going to be these little black switches, push buttons. Right, so we'll just plug them into our breadboard, just like you see the connection over here. Okay. So we got that. And we also have our speaker, and we know how to drive that one to pin number 4. And I have an example here on how the whole thing should work. This particular example, though, is just to test the sensors that you have on the top of the robot. Just like we did with the other ones, we can just copy and paste this. Right, and then we run it, and then we can test the sensors that are on the top of the robot. This guy's right here. There's also this final code, and what I'll have you do is I'll have you figure out at least how to integrate something like the sensors, or how to integrate these, either the sensors on the top or the sensors at the bottom. But I'm going to give you a lot of the code, and then you still have to do quite a bit of tweaking to match your robot's servo parameters. So, like if you recall, sometimes 1400 and 1600 values for a servo are completely different for somebody else's servo. So rather than have you spend a lot of time with that, you can or actually, because you'll need a lot of time to figure out these values, I'm going to give you a lot of the code, and from that code you'll be able to create your own algorithms for things like attack or search for the opponent, right? Going forward, going backwards, all those things. Okay, so we're going to be doing that, and I'll be showing you some demos right now on how to test the sensors and how this particular code works, a few more tips and techniques, and a little demo. Alright, here's some troubleshooting in case something happens. Be sure to make the manual adjustments to the IR collision detections if the robot is not seeing far enough. Right? Let me see. The other thing is, remember how to calibrate the servos in case the robot starts moving by itself once you download the program. Remember, you're going to use a switch to start the robot now, so your code has a code for switch in there. Check the cables. By now you have probably moved cables quite a bit. Make sure your batteries are good, and you may or may not need to adjust the sensor on the bottom, but we've used it for line following, so we know that that works. Alright, so let's start downloading some programs right now. Alright, so I just wire my switch to pin number 2. Right, so 0, 1, 2 on the sensor shield, and I have one pin going to ground and one to the signal. I have already wired this one from the previous labs on pin number 4. This is our little speaker, right, our piezo speaker. And the way piezo works, again, we can send a signal, right, like a up and down signal very fast, and then it triggers the material called piezo that creates a sound. So as long as you have it in an enclosure like this, then you have a vibrating sound out of it. Alright, so continuing with more examples here, we're going to do this is the same testing program we did to make sure that the line following sensors are working, just like we did in the line following lab. So I'm just going to copy that, and then I'll give you more info about the specs of that sensor. But let's just open up a new Arduino session here. Go ahead and run it. Okay, and it's done uploading. let's open up our serial monitor here. Alright, so here we go. Alright, so we can see that our sensors are reading 943. Now that's what is reading on a white surface. Okay, so the sensors below, right, are reading, they're basically reading that level. But if they're off the white, then they read very low numbers, right? The moment they go to the white surface, it's 943. Okay, so we know that the sensors are working. You can go ahead and add the A4 sensor if you want, because I only did, up to 2 of the sensors. But actually, this is not the program. This program, I only did a couple of sensors, right? Just the A2, A3, but we also have one on A4. If you want to plug it in, just finish the program. That's up to you. Okay, I'm going to delete that. We're going to continue here. So this is the little specs for those 3 sensors that are located underneath that. Now let's look at the top adjustable IR sensors as well. Now this will work the same with even some other sensors that are out there. But let's test out the top level sensors. This is the let's see. These are the sensors that you see up here, right? Our top level adjustable sensors that you see up here. We're gonna test them and make sure that they're working. These are nice because they have a light indicator in here. Whenever you get close to it, that LED, right, turns on. Okay. So they're a nice way to test them. But let's test them out on the screen with the software. So I'm gonna upload this. And a little bit more about what this is doing. So we have an LED on pin 13, which is the built-in LED. And we're saying that I'm going to test just one of the sensors on the top, the one that's connected to pin number 3. I'm going to say that the current value is low. Set up the LED as an output, set up the obstacle pin as an input. We want to see something on the screen, and I'm just going to read the values of that pin, and if it's low, then I'm going to say there's an obstacle in there, and I'm going to turn on an LED, right? If it's otherwise, just say there's nothing in the front, and I want to turn the LED off. All right, so let me upload that again. Remember that we wire the sensors differently, so that they're wired so that if it's a low value, it'll say that there is something. We can always just switch the wording around if you prefer, but we can just switch the wording around, and that should be the same. But let's try this out. Okay, I'm gonna turn the camera on, and it says there's nothing in the front. Now the moment that I put my hand in there, there's an obstacle detected, right? Again, it's because of the way that we wire the sensor, right? We're saying that if the obstacle is low, right? If the obstacle sensor is low, which it is currently low, then say there's an obstacle. Otherwise, say there's nothing in the front. Similarly, we could have set this to high, right? We could have set the sensor high, and we could have done the opposite. But remember, this is how we read the feelers, for example, right? This is active low. It's called active low. Okay, it's just the way that it's wired in a lot of industries. All right, so we know that those sensors are working. Let's move on to the next thing here. So I have this program that has been completed, and this is a Sumo, complete Sumo, but many of you probably don't have a Sumo ring yet. So So it's going to be there for you to test when you have that. But all you have to do is copy this whole thing and paste it in there. But what I did here is I got the two motors. I have the top infrared for collision avoidance and also to detect my opponents. I have my LED that turns on, the built-in LED. I'm declaring, by the way, these two infrared sensors as a Boolean, because all I need to know if there's a 1 or a 0. So I'm saving memory because it's kind of a long program. I'm saving memory in the system by declaring them as a Boolean. So I'm only storing a 1 digit in their value, right? 1 or a 0. I also have the 3 sensors on the bottom detecting for a white area, white line, for example. In this case, it's detecting a white line or a black surface there. And I'm declaring that the sensor value is currently 0. Okay, I have a button connected to pin number 2, and remember I did that very simple connection, and because I didn't have to wire a whole bunch of resistors, I'm able to use this function here called input pull-up. Okay, input pull-up, and this function allows me to use the pull-up resistors that are built into the Arduino processor, and this is why I'm able to connect them very simply like this, right, without having to use resistors and having to do my own pull down or my pull up with the resistor. I can just connect it right to the signal and ground, and I can make use of this function so that it can use the built-in resistors in there. Alright, so it's really neat. I would highly recommend to visit this link, because this is where you can learn about that particular function. Saves you a lot of wiring, a lot of components as well, and so glad that they did that. Just like the built-in LED on pin 13, it already has a resistor also, similarly to that. Okay, I'm using a new function here, and this is RC time, and it's meant to convert digital signals to analog values. Okay. And so we're using that to grab some of the values from the sensors. Okay, and based on that, we can continue on to our functions for forward, back. I also have like a spin right and a spin left. I have an attack function as well, right? And attack, it just means basically, hey, if I see you right in front of me, I'm going to go forward as fast as I can. Okay, and so this is my loop is looking for this whole thing here. Okay, and I'm just using my RC time function here to figure out the differences in the color of the surface, right, so that I can go forward or go backward depending on the situation. Okay. Now for this lab, because I assume you don't have a sumo ring, you're going to just use a piece of black tape or white in a black surface. It's up to you, but I want you to create a program. This is going to be on your own based on what you learned so far, that makes the robot stay inside a circle. Okay, so when I press this button here, it makes a beeping noise, and then it goes around here, and then it tries to stay within that circle. Okay, and you can use the top sensors, for example, so that if you put your hand near it, it goes back into the circle. Okay, so you're the obstacle. You're telling it, hey, go back into the circle with your hands in front of it, and by itself it makes sure that it does not crosses the line. But again, we're using the switch to start the program once you download it, and we make a beeping noise to tell us that the program has started. And that's it. Okay, so I'll be working on that solution right now, and to give you a demo how that would work. But all right, so I'm ready to demo the robot inside the circle, so you can see that it won't get out of the circle. Now I'm running out of battery here, but I want to show you one thing. I got this power pack somebody gave me, and I'm using the programming cable. It's from my power pack here. And I just want to show you that I can use that to give some juice to the robot, right? Because it's running out of power. But anyways, I'll do that. But remember, press the button to start the program, and you'll hear a beeping sound, and then the robot's going to go around by itself, staying inside the circle. So I'm just going to put this here, give it some juice with this one, turn the robot on, and press the button. Okay, so it should be just doing, you know, looks like it's about every 45 degrees or so. But anyways, it'll stay there doing that until it runs out of juice. But I wanted to show you that's how that works. Okay. Turn that off. Let me give you a tip of how I did this code a little bit. So I decided to use a line following example. So I just used a simple line following example, and I made sure that I took from the example that I do give you on the instructions from the Sumo. I took a few things out of there. I took out the button, and I also took out the input pull-up of the button. And then I did this while loop with the digital read, so I can press the button and I can do a little tone, a little sound, and then I run my whole program. But then other than that, it's just the line following program, okay, that you have done before with a few modifications. So I hope you enjoyed this one. This one was a lot of fun to figure out, especially because I wanted to show you how to do a simple one here. If you want to take it further, you could put something, make this bigger. If you have a white floor, you can put a huge circle there, and assign the sensors over here to go look for an object, you know, like a plush doll or something. Look for an object and then have it push it out of the circle without the robot getting out of the circle. Anyways, so that's further if you like to do that. But I hope you enjoyed it. Look out for videos for other projects, Bluetooth application, so that you can use your cell phone to control your robot and read sensors on your cell phone. And look for other ones for how to use an accelerometer, for example, and a whole bunch more. All right, have fun.
Is that off all the way?